My name is Bill Theisen, and I'll be presenting my paper, Motif Mining, Finding and Summarizing Remixed Image Content. I'm a fifth-year PhD student at the University of Notre Dame studying computer vision and online misinformation. I'm advised by Dr. Walter Scheirer, and I also work closely with Dr. Tim Weninger. Our innovation behind this paper and its algorithm is allowing non-technical personnel to quickly discover new trends in large collections of unsorted and unlabeled social media artifacts. The intuition behind this is that if they have access to emerging trends and motifs in online collections, then they can more quickly answer and respond to mis- and disinformation that is being spread. Normally, it takes quite some time to manually review the hundreds, thousands, and millions of images posted every day. To help alleviate this problem, though, we've developed this pipeline for motif mining to try and aid them in this discovery of online trends that threaten to devolve into misinformation. To test our pipeline, we collected a new data set of approximately 4.5 million Telegram posts that span 7 years that are related to the Ukrainian and Russian conflict, and the collection of this data set is still ongoing. On the right, you can see a distribution of the posts by year and by month, and at the bottom we have an example of the kind of posts that are in the data set. We tried to focus primarily on meme-type images in our data set, as we thought that this was both more interesting and less studied in the current literature, and it's also really rife with misinformation that is hidden behind layers of humor and sarcasm. To test our pipeline, we first extract image features, and then we build a content retrieval index using FAISS, Facebook's AI similarity search engine. Using the results from the CBIR system, we generate an adjacency matrix for the images that allows us to generate these motif clusters on the resulting graph. From the adjacency matrix, on the right we can see an example of what a motif cluster might look like. You can see it's a collection of 4 panel memes with a sub-motif using the NPC meme there on the bottom left. However, as human rights watchers were our end target for this pipeline, we wanted to ensure that the motifs were not just similar in a computational sense, but similar to humans themselves. And so to this end, we used Amazon Mechanical Turk to run an imposter host test. The details of this test are outlined in the paper, to assess which combination of image feature, graph type, and clustering method produced the most human salient motif clusters on the data set. The results of this imposter host test can be seen here. We compare to a prior work, which achieved approximately 60% accuracy and was then considered state-of-the-art. However, you can see here that some combinations of our pipeline achieve closer to 90 or 95% accuracy on this task, demonstrating a new state-of-the-art accuracy measure to be compared against in the future. We tested our pipeline across 3 data sets, and we ran hundreds of different combinations of feature type, clustering method, and graph generation techniques to try and find the best solution to this problem. If you have any questions, I hope you'll be able to stop by my poster, and I'm looking forward to speaking with you and discussing this paper further. Thank you.